So we have our curve sketching problem. In this curve sketching problem, we need to include all roots, asymptotes, critical values, critical points, points of inflection. You should also indicate where the function is positive, negative, increasing, decreasing, concave up, concave down. Basically, it's saying do all the analysis that we've done for each of our functions. So in the solutions that were posted, there was analysis done without any sign charts. It was purely a argumentative analysis, which is fine. But I showed in the course how to do it using a sign chart based analysis, which is also valid. So that's the solution that I'm going to create. So first thing we have with f of x is it's equal to x to the 3 over 2 minus x to the 1/2. First thing I like to do is I like to factor this. So this is x to the 1/2 times x minus 1. Now here, because of this square root, the domain is equal to 0 to infinity. So for x to the 1/2 to be defined, x must be greater than or equal to 0. So we have that domain constraint. And now we also have from here the roots are x equaling 0, 1. Vertical asymptotes as there is no value of x of a such that a directional limit as x approaches a grows without bound, there is no vertical asymptote. Now, another thing you could do is you could look at where am I dividing by 0 or taking the ln of 0? Nowhere. I never divide by 0 and I never take the ln of 0. Thus, no vertical asymptotes. For my horizontal asymptotes, I want to look at the limit as x approaches 0 in infinity of f of x and the limit as x approaches minus infinity of f of x. Now this equals the limit as x approaches infinity of x to the 1/2 times x minus 1, which equals infinity. And this does not exist as f of x is not defined for x less than 0. So because it's not defined, it doesn't exist. As neither of these limits approach a finite number, there is no horizontal asymptote. So there's no horizontal asymptote, there's no vertical asymptote. Now, to determine where I'm positive and negative, I like to do a sign chart. 0, 1, x to the 1/2, x minus 1, positive, positive, not defined. We're 0 here, we're 0 here, positive, negative, negative, 0 here, 0 here. Overall, positive, negative, undefined, 0, 0. So f x is greater than 0 when x is greater than, or x is in the interval 1 to infinity, and f of x is less than 0 when x is in the interval 0 to 1. And I'm going to create a nice little sketch just to give this information. And I like to create the sketch as I go. This is the point 1, 0, and this is the point 0, 0. Okay. So now I've done where's the function positive, where's the function negative, what are the roots, what are the asymptotes. There's no horizontal asymptotes, no vertical asymptotes. The roots are 0, 1. I've clearly labeled where we're positive or negative. I'm now going to look at analyzing the first derivative. So now I'm going to do f prime of x equals, and here I'm going to copy over that f of x equals x to the 3/2 minus x to the 1/2. So this becomes 3 over 2 x to the 1/2 minus 1 over 2 x to the minus 1/2. Okay? To get the derivative, doing the power rule I find is easiest. Now I factor. So it's 1 over 2 x to the 1/2 times 3 minus x. Or sorry, 3x minus 1. Okay. So to get the critical points are f prime of x equals 0, f prime of x does not exist. And x prime of x equals 0 are my roots, which is here, I'm going to factor this a little bit more to 3 over 2 x to the 1/2, x minus 1/3. Now it's crystal clear to me that the derivative equals 0 when x equals 1/3, and it does not exist when x equals 0. And it also does not exist when x is less than 0 from the domain restriction. But remember, for our critical points, these must be within the interior of the domain. So now I take these points and check to see if they're in their interior. As 1/3 is within the domain, it is a critical point. As 0 is not within, remember, even though it's in the domain, it's not within the interior, so it's not within the domain. It is not a critical point. And the textbook uses the phrase within to mean within the interior. So if you want to add within the interior, be my guest, it is not a critical point. Okay, and now the critical values. So our critical point is x equals 1/3. Critical value is f of 1/3, which equals 1 over 3 to the power 1/2 times 1 over 3 minus 1, which equals 1/3 to the 1/2 times minus 2/3, which is equal to minus 2 over 3 to the 3/2. And that's our critical value. So I have my critical point, my critical value. But now I want to determine where the function is increasing and decreasing. And to do this, I'm going to create a sign chart using both my critical point and the point that I thought could be a critical point, 0. All of these roots of the numerator and denominator, I'm still going to use. And I'm still going to base it around x or 3x minus 1 and 3 over 2, or sorry, x minus 1/3 and 3/2 x 3/2 and x to the 1/2. X minus 1/3 here, I'm undefined at 0 and I'm 0 here. X minus 1/3 is positive, negative, negative. 3/2 is positive everywhere. X to the 1/2 is positive and then not defined. So my function is the derivative is not defined, still undefined at 0. Then it's negative, positive, which means I'm decreasing, then increasing. Okay. Now, I haven't asked you to classify the critical points. So I haven't asked you to say whether it's a local minimum or local maximum. You're more than welcome to, but you don't need to based on how the question was labeled. But I need to tell you where you're increasing and decreasing. So f of x is increasing for x in the interval 1/3 to infinity, and f of x is decreasing for x in the interval 0 to 1/3. If I update my graph, I want to include my critical point and critical value. So that is simply the point here, 0 and 1. And it's this value here we said was 1/3, comma, minus 2/3 to the 3/2. And I'm decreasing up to this point, increasing after, and increasing after that. I don't know anything about concavity, but this is what I'm able to say thus far.